today's lesson, we're going to be simplifying radicals, specifically looking at square roots. First and foremost, let's define a radical. A radical expression is one that contains a root. In Algebra 1, we'll be looking a lot at square roots and cube roots. There are more roots beyond that you'll be looking at in future math courses. Let's kind of explain what the radical expression looks like. There's going to be a small number on the outside of the radical indicating what root it is, and we call this number the index. Again, we'll be dealing today with square roots, so we'll have a 2 there. If there's no index there, it's also assumed to be a 2. The radical symbol itself will be over what's underneath the radical, which is what we call the radicand. And we'll be breaking up that radicand and simplifying it down in the examples that follow. Let's go ahead and do our first example of simplifying the square root of 150. Again, it's a square root. When there's no number there, we know it's a 2. First step is I'm going to break down the radicand, the number underneath the radical, into prime factors using a factor tree. A factor tree starts like this, where I will be breaking up 150 into two numbers that will multiply back to the 150. I want to look for patterns as I'm going through these notes. So I think about that 150 ends in a 0, so I know it's divisible by 10. When I divide 150 by 10, I get 15. You know you have the right factors broken down into this tree if you can multiply the 2 in the same line to go back to the previous line in your tree. So 10 times 15 would indeed get me 150, but now we're going to keep going down our roots here. Breaking down 10, thinking of two numbers that multiply to 10, I have 2 and 5. I will stop there because they're both prime, which means that they are only have factors of 1 and themselves. Let's break down 15 into two numbers that multiply to 15, which are 5 and 3 here. Those two would multiply back up and get us 15 here. Now we're going on to step number 2, where we circle or highlight the same numbers. So I see at the end of my roots, my prime factors I have here, there are two 5s of the same number. If they make a pair, we can take them outside of the radical. So I'll take that pair of 5s, and since it's one pair, I write it once outside of the radical. Left inside underneath is going to be the 2 and the 3, two prime numbers at the end of my root that were unpaired and could not come out. Last but not least, I multiply any numbers in front of the radical because it's just 5 out there. 5 times itself is just 5. And then inside the radical, multiply any numbers inside there. Well, we have a 2 and a 3 left from being unpaired, so they had to stay inside, making it 6. 2 times 3 is 6 here. When I was thinking about numbers outside and inside, I did not account or do 10 or 15 because those were simplified down even more. You only look at the very simplified prime factors to write your final answer. So to help you out, cross out 10 and 15. You will never go back and use anything you broke down. Let's try the next example. I have to simplify 10 times the radical of 90. I'm going to start my factor tree. Again, remember our hint that if it ends in a 0, I know it's divisible by 10. And whatever 90 divided by 10 is, which is 9, goes next to the 10. I break down 10 into two numbers that multiply to 10, which would be 2 and 5. Two numbers that multiply to make 9 are 3 and 3. 2, 3, and 5 are all prime numbers, meaning they only have factors of themselves in 1, so I stop here. I notice at the end of my roots, my prime numbers, I have a pair of 3s and a solo 2 and a solo 5. Again, 10 and 9, cross them out. You will not include them because you simplified them down. You only look at the end of the roots, the simplified down prime numbers. 10 is not prime, 9 is not prime. They were also broken down, so we cross them out not to put them in consideration. Pairs come out in front of our radical. Every time we have a pair, we represent it once with the number that was paired, which was 3. And then inside, we have 2 that was left solo and 5 that was left solo. Before we simplify down and get our final answer, we cannot forget that in front of our radical, we had a 10 already there, which I would always multiply with the number I take outside the radical. Numbers inside the radical will multiply. That's why we get underneath the radical 2 times 5, 10. And numbers outside in front of the radical, we will multiply together to get us 30. Looking at our next example, we want to simplify 7 times the square root of 32. I think about 32, it's an even number, so I know it's divisible by 2. That's a really good pattern and hint when you're going forward with even numbers. So when I divide it by 2, I get 16. 32 divided by 2 gets us 16. Check your work. 16 times 2 works back up the root to the tree, giving us 32. 16, that might be a smaller number you might know some factors of. You can do different ones than the ones I do, but I'm thinking about 4 and 4, which I know 4 breaks down into 2 and 2 each time. At the end of my roots, I am circling any pairs of 2s I have. So right away, let's cross out 16, 4, and 4 since they were broken down. I'm only looking at these pair of 2s here at the end of my root on the right, these pair of 2s at the end of the right root in the middle, and the solo pair of 2 that I had up at the top at the end of a root. Only look at the prime numbers, and I crossed out any ones that were not prime and were already broken down. From here, any pairs I multiply in front with the 7 that was already there. So I have one pair of 2s, so I'm going to represent a multiplication of 2 there. And because I had a second pairing of 2s, I need another 2 to be multiplied outside in front of my radical here to represent that there were 2 pairs. Inside, what was solo and left unpaired was the 2. 7 times 2 times 2 will give me 28 outside, and radical 2 left inside of the radical. Remember, anything left inside gets multiplied together, and anything left outside gets multiplied all together. In today's lesson, we're going to learn about simplifying cube roots, and it starts with talking about what a perfect cube is. A perfect cube is when you multiply the same exact number 3 times. We are going to go ahead and list some perfect cubes, starting with 1. If I have 1 and cube means to put that little 3 exponent after it, I'm really doing 1 times 1 times 1 to give me my answer of 1. 2 cubed here again would be 2 times 2 times 2, which gives me 8. 3 cubed is 3 times 3 times 3, which gives me 27. 4 cubed is 4 times 4 times 4, which gives me 64. 5 cubed is 5 times 5 times 5, which gives me 125. 6 cubed is 6 times 6 times 6, which gives me 216. 7 cubed is 7 times 7 times 7, which gives me 343. We'll kind of stop there. We're not going to go much higher than that. And we'll go ahead and try the negative of these options. So that means if I cube -1, that means I'm multiplying by -1 times -1 times -1. In the end, that's going to result in a -1 because -1 times 1 makes a +1, but then you again multiply it by this -1 and it gives you the result we have here of -1 overall. So in this format, -2 cubed will give me negative 8 when I multiply 3 2's together. 3 cubed, that is negative 3 cubed here, will give me negative 27. Negative 4 cubed will give me negative 64, and it's really important that I put these negatives in parentheses. That way I do include them and attach them with the base of this exponent of 3. Only way that they will turn out negative is if they are put in parentheses in the first place. Negative 6 cubed is negative 216. And negative 7 cubed is negative 343. So again, make sure that the negatives are in the parentheses, indeed applied to the base of that exponent of 3. If it's written like this, like negative 7, 3, you would do 7 to the power of 3 and then multiply by negative after. That's important. We're now going to go ahead and simplify cube roots. So how we do so is break down and write a factor tree. So we think of factors of 72. We have 8 and 9 that would multiply back up to get us 72. Break down 8 into 4 and 2. Again, two numbers that would multiply back up to 8. And then 2 and 2 at the ends. When we're writing the answer, remember we're only looking at the roots, so cancel out anything you just simplified, like the 4 and the 8 and the 72. When I break down 9, cancel it out. We're breaking it down into 3 and 3, and I look at those final numbers I don't cancel out to get my simplified cube root. It's also a cube root in this problem, we know, because of the little 3 index on your square root. This now means, and this is important, so circle this step, that you have to circle or highlight triples instead of doubles like we did in the previous lesson. So I circle any that have 3 of a kind, which is my 2's there. This pairs of 3's are great, but they do not have 3 3's at the end of my roots, so they must stay inside the cube root. Make sure when you write the cube root, you keep that little 3 index attached to the root. From here, we go ahead and simplify down by leaving 9 inside because the two pairs of 3's get multiplied together to make 9. On the outside, I took out my one triple of 2's here. So that final answer, simplifying this radical down, will be 2 cube root of 9. Let's try another one. The next one here, we want to make note, and you can write this down. You can have negatives in cube roots. When simplifying, take the negative out of the radical first step. So that's exactly what I'm going to do here. I'm going to take the negative, and that's really going to be a negative 1 in front of my parentheses there. I'll bring it down with my answer, but let's break down this factor tree for 500. Factors of 500, well, I know it ends in 0, so it must be 10 with a number, in this case 50. Again, 10, it will break down into 5 and 2. 50 breaks down into 10 and 5. And then 10 breaks down into 2 and 5. Cancel out anything you simplified. I simplified the 10s, the 50, and the 500. When I'm circling for triples, 3 of a kind, I know because of the 3 on my index, I have to circle all 3 5's here. When I circle them, I'm able to take them out and multiply them with the negative 1 already there. I represent the triple 5's with 1 5. That's one triple I can take out. Left inside my radical will be these double 2's we have here at the end of my roots. Multiply the outside numbers to get your final answer here. Well, negative 1 times 5 is going to give me negative 5 on the outside of my radical. On the inside of my cube root here, I have 2 times 2 left inside that I will multiply together to get 4. As my final answer, it's -5 cube root 4. Last example before we add variables here, we have 40 underneath the cube root, so I know I'm looking for three of a kind to be taken outside the radical. Let's see if I have any. 40 is ending in a 0, so it's divisible by 10 with 4. I break down 4, so cancel that out along with the 40. Those have been simplified all the way down to the prime numbers of 2 and 2. Again, stop when you only have a factor of 1 and the number itself. You don't want to go that far. You want to stop at those prime numbers. From here for 10, we have 2 and 5 that will multiply to get us 10. Again, those are prime numbers, so stop there, but cancel out 4, 10, and 40 because you broke those and simplified them down. You only look at the prime numbers to write your final answer, as well as ones at the end of your roots. Any triples, because of that index again, we can circle. I have 3 2's that I will take outside my radical. Remember, it's only one triple, so I only write one of the number tripled, which is 2. Here in front of my radical, don't forget you had the 6 already multiplied out in front here. So 6 times 2 will happen outside my radical. Inside the cube root radical, the only thing left not crossed out or circled is that 5 I underlined. So underline the 5. It has no three of a kind, no triple to take outside the radical. Last but not least, we multiply the outside number. 6 times 2 gets us 12. Inside, there's nothing to multiply, so it just stays 12 times the cube root of 5. Let's add in some variables. We can also have variables inside the radical. Write out how many you have and still find doubles for square roots. So I'll go ahead and start with my number here, 49. Breaks up into 7 and 7. Then I have a squared. Like I said, write out how many a's you have, which is 2. As you can see, I can pair up the 7's and cross out the 49 since I simplified it. I can pair up the 2 a's I have and cross off the a squared I originally had. Remember, whatever I circle goes outside the radical with the negative. That's truly a -1. So I'll have -1 times the pair of 7's I took out times the pair of a's I took out. And then my final answer will go ahead and be -7a. Nothing left in the radical because I paired everything to come out. For the next problem, I go ahead and simplify -3 square root 40x cubed to y to the 5th. So again, I'm going to break down my 40 into factors. 5 and 8. 8 breaks down into 4 and 2. And then I'll break 4 down into a pair of 2's here. Remember, with my numbers, I cancel out everything I simplified. I circled 2 of a kind since I'm dealing with a square root, and I'll underline what I have that will be left inside. For the x's, I have 3 of them, so I'm going to write out 3 x's here. Notice that I can pair up one pair of x's and then leave one inside. Then I'll also have 5 y's here, so I'll write out all 5. And then I'll pair up the ones I can. Looks like I can have 2 pairs with 1 y left inside. So when I draw my square root, anything underlined, I'm going to multiply to put inside. 5, that will be multiplied by 2. That will also be multiplied by 1x left over, and then times 1y left over. Outside, I have the -3 I cannot forget to bring down from the problem. I'll multiply that by the 2 I circled to bring outside, as well as the x I circled as a pair to bring outside. And then I circled 2 pairs of y's, so I will make sure I have 2 y's outside. And the easiest way to do that is y squared. That symbolizes 2 y's outside.
Multiplying my numbers outside, I get negative 6xy squared. Square root inside a 10, because that's what 2 times 5 is, xy. We're also going to have variables inside the radical for cube roots. So again, same thought, just going to go ahead and look for 3 of a kind or triples now since it's a cube root. Still break down the number the same way. So I can break down 162 into 2 and 81. Break down 81 into 9 and 9. And keep simplifying till I can't anymore to 3 and 3 on both 9s here. Remember, I crossed out anything I simplified and broke down. I circle 3 of a kind this time, and I underline what's left over. Writing out my A's, I have 4 of them here. I triple up as many as I can, and I have 1 left over. Same thing with the B's. I go ahead with my B's, have 3 there, so I write 3 out, and I triple them up. It looks like none will be left inside. Everything I tripled up goes outside. The triple of 3's. I'll make sure I write my cube roots so I know it goes inside and outside. The triple A's go outside, and the triple B's. Left inside is the 3 times the 2, as well as times a lonely A that could not be tripled up. Final answer when we simplify this is 3AB, cube root of 6A. And the next problem, I'm going to start by taking the negative out first and rewriting this. Always, always, always when you have a negative in your cube root. And then I'm going to start breaking down 27, my number. 3 and 9 are 2 factors of 27, and then 3 and 3 are factors of 9. Canceling out 9 and 27 since I simplified them, and circling the triple 3's. X to the 5th means I'm writing 5 X's out here. Triple as many as I can up, and I see that I have 2 left over that will remain inside. Outside my radical is the negative 6 I already had, times the triple 3's I was able to take out. And don't forget I already had an X there outside. I'm bringing down the negative 6 and the X already there, and taking out the 3 I circled. I'm also taking out the triple X's I circled here. And then inside my cube root will be the 2 X's left inside. Again, a great way to show when you have more than one X is using the exponents we talked about before. Multiplying negative 6 times 3, that's negative 18. 2 X's, I'll simplify it to X squared. And then I have the cube root of X squared after it as my final answer. We're going to look at some SOL type questions with Desmos. What is the equivalent to the square root 80 in simplest form?